All right, so now new lesson. We're skipping 3.3, okay? We did 3.2 was the last one we did, so I'm skipping 3.3. I don't even know what it's over, but I skipped it before, so I'm skipping it again, all right? Yeah, you'll probably be glad, I guess. There's probably a reason why I skipped it. All right, this stuff is good. This is one of those lessons where, man, you're going to hit a lot of important stuff that you're going to need to know. Some of the stuff you probably did in Algebra 1, okay? You'll definitely do in Algebra 2. In fact, I'm getting ready to teach a lot of this stuff in Algebra 2 right now. They don't teach it, I mean, they teach it very briefly. You know, they just hit it, jump off of it, and then go to tougher stuff. But what we're doing right now, what I'm doing first right now, I'm actually going to teach us in the next class, in Algebra 2, Honors Algebra 2, all right? The exact, at least the first part of what I'm doing. So that's kind of interesting. All right, so let's talk about it. Let's talk about this word first, an ordered pair. Have you heard of that before? Yeah, that's definitely an Algebra 1 topic, an ordered pair. So we have a parentheses and we got a comma. What goes in here and here when we talk about an ordered pair? X and Y. Very good. What goes first? The X goes first and the Y goes second. All right, so that's an ordered pair. Now listen, it's an ordered pair, so it has to go in that order. Obviously, pair means what? 2, and it has to be in order. The X has to go first and the Y has to go second. All right, we call this a coordinate. Have we used that word yet in here? Seems like we did. I get mixed up sometimes what class I say what in, but and so a lot of times we'll call this thing a coordinate. Sometimes we'll call it a coordinate plane, or a lot of times they'll call it a rectangular coordinate system. All right, so that's a long word for that. So the stuff we're doing could be called this, but a lot of times it's called this, and it's named after a person. I don't know if you've seen this before. Cartesian. Have you seen that before? Call it our Cartesian plane or a Cartesian system, however you want to say it. It's named after somebody. Who do you think it's named after? What is it? Cartesian? Cartesian is how you say that, Cartesian. So the guy's name's not Cartesian, but it's kind of like that. He's a guy, but he's got, now in France, this would not be a girl's name, but René. So the guy's name is René, even though it's a guy. But in French, René would be considered a guy's name, I guess. I don't know. I guess girls' names could be that. But it's René Descartes. It's Descartes. Couple silent S's in here, right? In France, they have a lot of silent S's, and so it's Descartes is how we would say it. René Descartes. So he's a French guy, French philosopher. Okay, he's a mathematician, he's a scientist, he did a lot of things. And he lived from 1596 to 1650. So he was just a little younger than I am right now when he died. I don't know very much about him, but that's what we have right there. I do know that he was a deist. D-E-I-S-T. From what I understand, I did read a little bit about it today because I'm teaching this in my next class. And I looked him up a little bit and just read briefly a little bit about him. I don't know much about him, but just a little bit. I think a deist is, they believe that there's some kind of greater power, right? Some kind of, but they don't really believe it's God like we believe it's God. They don't believe, that it's a person that knows us personally, that kind of thing. And that's what we believe. But he believes that there is some kind of maybe creator or something that puts order into the world. But what they basically believe, there's probably a lot of variations of this, but they kind of put their trust in science. You hear that today a lot. If you follow politics at all, you'll hear so many people talking about they're putting their faith in like the climate change. You've heard of climate change, right? They're put their faith in all these scientists and things like that. It's not, to me personally, as a Christian, I don't do that. I don't put my trust in somebody else. Like I might have a political candidate that I like. I might have a pastor that I like. I might have somebody that's in charge that I like, but I don't put my faith. I don't put the rest of my eternal existence, right, based on a person, a man, okay, or a woman. So they kind of base it on science a lot. So that's what I understand. He technically was a Catholic, but I think I don't know if he grew up, but I know he spent a lot of time in Holland, right, or the Netherlands, right? You ever hear that? Yeah, it's the same country. I don't know why I don't know the difference between calling it Holland and the Netherlands. I don't know. But when they play sports and stuff, they always say this team is from the Netherlands. I don't know how that works. Maybe like United States and then America, maybe. I don't know. But anyway, so look him up. It's kind of interesting. But apparently he came up with this thing that we're going to do. All right, enough about him. Let's do this. Nah. I was just interesting stuff. That's all. You're not going to be quizzed on it or anything like that. But it's just nice to know where some of these names come from. So this thing that I'm going to draw right here is called the Cartesian plane. Right? A lot of times we will talk about that. So let's talk about this. I'm going to put some arrows on these thing right here. All right, this one going horizontally, we call it the x-axis. Again, this probably is not new to you. You probably know this already. That's my guess. Am I right? Did you learn that this is the x-axis, that's the y-axis? Yeah, by the time you get up to where you are now, you've probably heard that stuff before. It's also separated, so this horizontal one is the x-axis. That's supposed to be an A, kind of weird looking. X-axis, and then the y-axis. So the horizontal is the x, the vertical is the y. All right? And you got these 4 areas, let's say. Okay, do you see this big area right here, 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 and here? Those are areas, and we give that a name, and we number them. We number them using Roman numerals. Don't know why, but they do. That's Roman numeral 1, and then you go counterclockwise. So what would this one be? This would be 2, 3, and 4. Do you know what they're called? What those 4 sections are called? Say it. Quadrants. Very good. Okay. Obviously, quad meaning what? Right. And then it's just 4 spaces, 4 areas. So this whole area in here is the first, the second, the third, and the fourth quadrant. All right, let's do some more. We have a place where these two I'll say this. You have one axis, but you have 2 what? Is it axes? It's axi. That would be kind of cool, but it's axes. All right, so that's the plural. I'll put a PL after it. That's the plural for axis. So you have one axis, but you have 2 what? Axes. Okay, so that's the plural. So you've got 2 axes, the x and the y axis, and if where they intersect right here has a special name. Anybody know what that special name is? I think I heard it. What did you say? The origin. Very good. What does it mean if I say the origin? Yeah, it's 0, 0, but it's just as far as the word origin in general. Anybody know? The beginning, exactly, okay? It means the beginning, all right? And so this is where we always start. A bug? Well. Yo, that's weird. Well, Ian, can you grab it? Grab it? Here, get a tissue. Just get a tissue. Well, it's a cricket. It's supposed to jump. Here, get a tissue. Ian, who's not afraid of a cricket? Okay. Get a tissue. All right. Pick it up. Throw it out throw it out one of my windows. It's open right here. Don't kill it. Don't kill it. Just grab it. I gave you a tissue. All right. Natalie's not afraid of it. I know. I'm Natalie. Don't kill it. Did you get it? Come on. Wasting my time. All right. Don't squish it. Use your fingers. All right. Let it outside. She's scared of it as she's holding it. Watch it jump on you. Did you get it? All All right, good. Well, that was exciting. All right. So the origin, listen, the origin is where you begin, okay? So when we're going to do some stuff with this, we always begin right here at the origin. And remember what we said first of all, coordinates, all right? What's first? X, then Y. So we always start at the origin, and then you go in the X direction first, and then you go in the Y direction, okay? That's why it's called an ordered pair. You have to go in that direction. So if I wanted to find out where I almost gave it away. Somebody said it already, so I'm sure you know this. The origin is at 0, 0, because that's 0. Now, if we go to the right, what kind of numbers do we have to the right? Positive. And if you go to the left, you have what? Negative numbers. I'll put that in parentheses like this. And if you go up on the y-axis, what is that? Positive. And if you go down, it's negative. All right, very good. Again, this is things that you already know. All right, so if I wanted to... 3, 1, 2. I won't go real big. We'll just go real little numbers here. Sometimes they'll use the word plot, okay, or they'll say graph. Plot or graph. They won't say both, but they'll say one or the other, okay? If I wanted to plot a point, right, they'll give you the point. And this shows you how to describe a point, all right? So if I wanted to go right here, okay, where would that point be? Well, I start at the origin, and I always go in the X direction. In order to get to this point, I can't just go directly from here to here. I have to go left and right, then I go up or down, okay? So which way am I going to go? To the what? To the right, how many places? 2, and then I'm going to go up how many places? 3. So what's the ordered pair for this? It's 2, 3. And it's positive, isn't it? Yep, because I went to the, well, both of them are positive. I went to the right, and I went up, both being positive. We okay? All right. What if I asked you to plot -3, -3, 1? You start at the origin, and where do you go? To the left, how many? 3, and you go up 1. Yep, so right there. Okay, and sometimes they'll do this. They'll put a letter in front of it, and they'll say graph this or plot it. I think they say graph. All right, -3, 1. So what do you put next to that point? Put a capital A, because that's point A. All right. Let's do one in each quadrant. Then we'll do one on one of the axes. Give me a good point in the third quadrant. -2, what? -2, 1? -3. Okay, so -2, -3. So you go to the left 2, you go down 3. It'll be right there, and that point would be -2, -3. Give me one in the fourth quadrant. What is it? 3, -3? All right, 3, -3. That would go right there on where the 4 is. All right, but that's okay. There's 3, -3. Okay? So in the first quadrant, what are my signs always going to be in the first quadrant? It's going to be positive, what? Positive. In the second quadrant, my signs are always going to be what? Negative, positive. And in the third, negative, negative. And in the fourth, positive, negative. Okay? So that's always nice to know. What about if we go right on the line itself? What if I put a point right here, right on the x-axis? What is the ordered pair for that point? Is it 0, 2? Start here, and you always go in which direction first? You go left or right, the x direction. So how far do we go? We go 2 to the right. Okay, so that's the first one's going to be 2. How far up and down do we go once we're here? You go 0. You didn't go up or down at all, do you? So what would that point be? 2, 0. Okay? What about this point right here? What would that point be? It's 0. 0 is first because look, in order to get up to here, how far do you go left or right? You don't go anywhere. You go 0, correct? So you go 0, and then how far up do you go? 3. So that point would be 0, 3. What about this point down here? I know there's a lot of stuff going on here, but just follow me. What about that point right there? What's that going to be? It's 0, what? -1. Okay? And let's do one more. Let's do this one. Right there. What's that point? This point right here. That's it. -2, 0. Everybody good with that? All right, that's super important. Okay, this is real basic stuff that you probably already learned before. Am I right on this? You did this in Algebra 1, sure. All right, so it's really important stuff, but it's gonna really help for what we're gonna do next. All right, now we're getting out of the baby stuff, and we're gonna get into some real stuff here. Okay, everybody good? No? Sure you are. You don't want to just rely on that little stuff, but it's not little because it's not important. It's very important because we're going to definitely use it right here. Let's add some color, man. I've just been black and white here, haven't I? Let's put some red in here. All right, so what if I put just some general point, just some point right here, and let's put that point right there. We'll call this point A, we'll call this point B, and I'm going to connect those points together. Because what I want to do is I want to find out, using X's and Y's and all that kind of stuff, I want to figure out the length of line segment AB. Okay, I want to find out how long that segment is. Now, we're not going to find out, I'm not going to say like it's 7 inches or 12 feet or whatever. You'll see what I'm going to do here in a minute. But I want to get a formula. Okay, we're going to develop our own formula. I could sit here and just say, okay, here's the distance formula. Here's the formula. This is, excuse me, this is how you use it, and then go on to the next thing. But I like, especially with an honors class, I like you to see where this came from, okay? I don't want you to just see it and say, man, I need a cough drop or something. I don't want you to just look at it, the formula that we're going to do, and say, okay, that's nice, I can use it and all that stuff, but I have no idea where it came from. I want you to see where it came from. So I'm going to go as quick as I can on this. So this point, let's put some other colors in here. This point right here, A, it's going to be an X and a Y, isn't it? But this is also going to have an X and a Y in it. All right, we're not going to put actual numbers in just yet, all right, because this is very general. This works for any 2 points, the distance between any 2 points. So I want to be very general. So I don't want to just call this X and Y and this X and Y because they're 2 different points. So what I'm going to do is I'm going to call this X1 and Y1. You follow me? Because what do you think I'm going to call this one then? X2, good. X2 and Y2. Do you see that? It's just so that I can differentiate between the 2 X's, right, and the 2 Y's. So this is my first XY, this is my second XY. You can think of it like that. Does that mean we square it or multiply it by 2 or anything? Nah, it's just the name of it. Just X1 is different than X2. Y1 is different than Y2. We good with that? All right, so what we're going to do is, again, different colors. We'll go real colorful on this. What I want to do is this. Okay? Now, this always throws people for a loop, but see if you guys can figure it out. In terms of X1, Y1, X2, Y2, what do you think this point right here is going to be? Now, we're not going to go X3. In terms of, listen, in terms of X1, Y1, X2, or Y2. Did I say that right? Whatever. I'm not going to call it X3 and Y3. This point right here, how far did you go over? You went over this far, didn't you? What's another point on here that you went over to the right, the same exact distance? X2. Good. See this point up here? How did you get to that point? You started here and you went that far, didn't you? All right. So how far over did we go? X2 to get here. So this point's directly below it. What's the X part right here? That's also X2.
And then Y1.
Okay, everybody see that first part though that I did? How far over is this blue one right here? You went over X2 because you went over X2 to get to that point. This is directly below it. And then now, how far down did you go?
Y1.
You went Y1, right? Because this point You went down this far, that y1. So this point's going to be what? y1. So that's the weirdest part. It's probably the most confusing part of the whole thing. Now, I believe we discussed in the first chapter how to find the distance between 2 points. You remember that? All right, so remember if we had a straight line. I just finished teaching this in my CP class, but you guys had it a while back. All right, so let's say you're at 3 here and you're at 10 right there. How do you find the distance between those 2 points? Yeah, you subtract, right? So 10 minus 3. Remember, it was absolute value? Okay. Remember this? Yeah. So what are we going to do here? So let's scooch it up just a little bit. Let's make one of these a different color just so I can refer to the colors. We'll go green. Okay. Let's do the blue one. I want to find the length of the blue one. Now this goes horizontal, right? So it shouldn't be too hard. So what letters am I going to deal with? The X's. This goes horizontally, right? So I'm only going to deal with the X's. So how do I find the distance from this point to this point? That's right. Just subtract the X's from each other. Okay? You got it. All right. So this, close. So if you went, here, we'll just do it right here. If you say that the distance, right, equals x2 minus x1. And again, it doesn't matter which way you subtract them. Well, actually, you were fine with saying that. I was thinking of something else. But yeah, you're fine. What is it? What's the distance from here to here then? What would you subtract now? Not the x's, but the what? The y's. Since I went x2 minus x1, let's go what? y2 minus y1. Okay? So that's the length or the distance from this point B to, we'll call that C, right, to C. You with me? But what are we trying to find? We're trying to find the distance from where? Point A to point B. Now this is slanted, right? So we can't just subtract anything. But we did find this length and we did find this length. Now, I don't know if you remember this, but do you remember if you had, well, let's see. Let's go back to white. Come on. There it is. All right. I don't know if you remember this, but if you have a right triangle, I bet you anything you studied this before you came to geometry. Well, my guess is that you did, but, you never know. If I call this A, and I called this B, and I called this C, does this ring a bell at all? Very good. So, yeah, I knew you learned this. Good. So watch. A squared, I'll tell you what. Yeah, we'll do it like that. A squared plus B squared equals C squared. We gave that a name. Again, it's named after a guy long before Descartes. Close. It's Pythagorean theorem. You basically got it. I would have known what you were saying, but you just didn't quite pronounce it exactly. Named after a guy, Pythagoras. He actually lived before Christ did. All right? He goes back way beyond the 1500s. All right? Pythagorean. All right, Pythagorean. So it's named after Pythagoras. We're not going to talk about that because we're running out of time. So, do you remember how to do this? You went a squared plus b squared equals what? C squared. Or, is it okay if we just switch it around like that? Yeah. I mean, normally we memorize Pythagorean theorem as a squared plus b squared equals c squared because a, b, c goes in order. Yeah, it makes sense. It's easy to memorize it that way. And that's how I would teach it. But what we're going to do right now, my C is this red line, isn't it? What is the C here? Give me a word. We haven't really talked about it, but it's the H. It is high something. Hypotenuse. What? You haven't heard that word before? It's the side that's opposite the right angle. All right, I'll write it down. Hypotenuse. Hypotenuse. All right. It's the side that's opposite the right. Okay. All right, so the hypotenuse is always, listen to me, the hypotenuse is always opposite the right angle. Now, this book is working under the assumption that you've already learned this stuff, all right? So that's why I'm going kind of quick on it. So the hypotenuse is always the side that's opposite the right angle. So which one is the hypotenuse on this colorful triangle? Which one's the hypotenuse? AB, right, the red one. All right, that's the hypotenuse. So what I'm going to do is this. The hypotenuse, we're going to call it D for distance. Is that all right? So I'm going to call it D, all right, for distance. And let's go back to white again. All right, so am I just going to write D equals? No, what's this? What do I have to do to that hypotenuse? I square it, right? So the hypotenuse squared is equal to, now, these are called the legs. The other two sides are called the legs of the triangle, all right? Noah, fight it. Okay, fight it. I know, I can see it. I know you're not trying to, but try to fight it. All right, so what's the a squared in here? Give me a color.
Green.
Okay, you can either one. It doesn't matter. You can go either one. Let's do the blue one, all right, since it's X, all right, and that's first. So watch what it is. What's the length of the blue one?
X2 minus X1.
You got it. And what do we have to do with that length?
Square it.
We got to square it. Plus, not double it. No, no, no. It is not doubled. Squaring is not doubling. Yeah, but don't say double because that's not the same thing. All right. What's the other side? The green one. What's the green one?
Y2 minus.
You got it. Y2 minus Y1 squared. I'm going to show you one more thing. Well, I might show you a little more. We'll do an example, hopefully. I think we have enough time to do an example. But I will show you one thing before we actually finish writing out our distance formula. So this thing is going to be called the distance formula. To tell you the truth, what we have written already would be okay to memorize, but I'm going to show you what they do. They don't write d squared equals. They're going to just write d equals. So how do I get d by itself? How do I get rid of something that's being squared? Well, how do I get rid of anything in algebra? I always do the what? Opposite. So what's the opposite of squaring something? No? The opposite of multiplication is division. The opposite of addition is subtraction. The opposite of squaring something is taking the no.
The
Square root. Very good. Okay, I knew I'd get it out of you. All right, it's taking the square root. So watch very carefully. This is something you may not have done a lot of, but I'm going to show you right now. So I'm going to take the square root of this. Now, what happens if I took something and I divided it by the same thing, it would cancel out, right? If I took something and subtracted it from the same thing, it would cancel out. What do you think the square root and the square do to each other? They cancel each other out. That's right. But remember in algebra, whatever you do to one side, you've got to do the other side. So watch very carefully. I'm going to also take the square root of the whole entire right side. Looks a little weird, looks a little ugly, but after you get used to it, it won't even bother you a bit. All right? So what happens to the square root and the squared? They cancel out. Now, you would think that that square root cancels out with that squared and that squared. But this is being added, okay? If we had more time, I could take some numbers and put it in here and just show you that this square root does not cancel out that squared. This square root does not cancel out that squared because these two things are being added together, all right? Just take my word for it, okay? Because we don't have enough time to talk too much about it. So that's your formula right there. Let's write it nice and neat, though. So the distance equals big old square root. And then here's what I do. Everybody watch before you write. Everybody look at me. If I was going to write out the formula, which you are going to many, many times, all right, here's how I started off. I go something squared plus something squared. What goes in here? X what? X2 minus X1. What goes in here? Y2 minus Y1. Well, it actually doesn't make any difference because, watch, if I went let's say x2 was 5 and x1 was 3, okay? What's 5 minus 3? 2. What's 2 squared? 4, okay? Let's do it the other way. Let's go 3 minus 5. What's 3 minus 5? It's negative 2. But what happens when you square a negative? It just comes out positive anyway. So does it matter what order you put the x2 and the x1 in? Doesn't make any difference, okay? It will be, because that's how you find the distance between 2 points, right? You don't add, you subtract. See where that came from? All this. I thought that was kind of fun, right? To see where a formula comes from. Like I said, I could have just thrown you this formula and say, okay, this is how you use it, and then everything would be fine. But I like the fact that you see where it came from. Denise. Well, these are the coordinates, right? So let me do an example, okay? Do a real quick example, and I think we'll probably finish there just because of time. This was going to be an A and B assignment anyway, so I wish I would have gotten a little bit further, but this might turn into a 3-day thing. So here's example 1. It says find the distance. Find the distance. This is very easy to use. Once you learn the formula, and you have to memorize it. Okay, that distance formula, you got to memorize it. I'm not going to put it on a quiz, and I'm not going to put it on the test. And it says between these 2 points. So they'll give you 2 points, like that A and the B. But this time they'll actually tell you what the numbers are. Okay? And we'll get an actual number answer. Sometimes the numbers are really weird looking, but you'll see. All right. So there's my 2 points. If you wanted to, at first, this might be helpful. This is x and y, this is x and y, correct? So that's my first one. So this is going to be my x what? 1, and this is going to be my, no, it's a y. It's a y1, okay? Remember, it's x and y. This one's going to be what? x2, and this one's going to be y2. Good. All right, if you want to do that at first, it helps, okay? Do it for a first few. After a while, you're not going to have to do that anymore, all right? So now, let's put it in our formula. Here's what I would suggest that you do. Every time on a homework problem that you have to use the distance formula, I would write the distance formula every single time. Why? I mean, you could just write it at the top and look at it all the time, but I would write it every single time. Why? To memorize it. That's right, okay? To make sure that you remember what it is. So I'm going to write it. So here's what I do. I put all this, I call this the shell of the equation or the formula, right? Because I really haven't put the guts in it yet, have I? This is just like the outside of it, all right? So what do I put in here? x2 minus x1, y2 minus y1, right? And now we can apply it. So I would do that every time you have a problem on this assignment. I would do that every single time. And then that way you're going to memorize it, okay? So here we go. I'm going to put the shell again, but I'm actually going to put the real numbers in this time. After a while, you won't have to write that formula down. You already have it memorized. You already know to write this shell down. Now we can stick the numbers in. Now again, it doesn't matter what order you subtract the x's in. It doesn't matter. But since we put x2 minus x1, let's do that. So what's my x2? It's 4 minus what? Negative 2. You got to be, it will be in a second. I'm going to put the negative just so everybody sees that, okay? So it's 4 minus negative 2. Don't just put 4 minus 2. That'll be completely different. Okay, it's 4 minus negative 2. Let's do the same thing with the y's. So it's going to be what? Well, let's go y2 minus y1. Yeah. Now, you could just go 5 minus 1. It wouldn't make any difference, okay? But I'm just getting us used to doing it in the same order, okay? Now, it's just arithmetic, really. That's all it is. It's really not that hard after you stick all the stuff in there. That was the work. That's the bulk of the work right there. Now it's kind of easy. What's 4 minus negative 2? Right, that's plus, and that's going to be a 6. I'll put the squared just so you don't forget. What's 1 minus 4? Or, sorry, I gave it away. What's 1 minus 5? Yeah, technically it's negative 4, isn't it? And I'm going to put that in parentheses and square. All right, 6 squared is 36. Plus, now when I square a negative, it just goes to positive anyway, doesn't it? So what's 4 squared? 16. And then keep it under a square root. What's 36 plus 16? 52. Okay. Now you could keep that as your answer, and I'd be perfectly fine. You could say distance equals the square root of 52. I would be perfectly happy with that, but you could also put it into a calculator. If you put it into a calculator, watch, I put a couple squigglies. Why did I do that? Because it's not uneven, it's what? No, it doesn't repeat. What is it? It's an estimate. It's an approximation, okay? So this decimal will keep on going, right? And it won't repeat, okay? It'll just some random, whole bunch of random numbers, all right? So I just rounded it to the 10th place. And so if you like decimals, and it depends on what they ask for. Now, your official assignment is to do 1 through 22. But I don't know, listen, I don't know if it asks for midpoint, you've gone too far, okay? Just do the ones where it asks to find the distance, okay? There might be some other stuff at the very beginning of it, but stop after you have to find the distance between 2 points, okay? As soon as it starts asking for midpoint, stop there. Everybody got it? Again, I don't have the book in front of me, so I'm not sure what number that goes to. But do as many of these as you possibly can. We good? All right.